Hi! Today, we will learn about proportionality theorems. Here are the proportionality theorems. Basic triangle proportionality theorem, or BTPT. Converse of basic triangle proportionality theorem. Extended parallel proportionality theorem, or EPPT. And triangle angle bisector theorem. Let's discuss one by one. Let's first have the basic triangle proportionality theorem, or BTPT. BTPT states that if a line intersects two sides of a triangle and is parallel to the third side, then it divides the two sides proportionally. Say, for example, we have triangle ABC. If XY intersects side AB and side AC, and if XY is parallel to BC, then we can say that the two sides, side AB and side AC, have been divided proportionally. The ratio of AX to BX is equal to the ratio of AY to CY. Let's now have the converse of basic triangle proportionality theorem. The converse of basic triangle proportionality theorem states that if a line cuts two sides of a triangle in proportional segments, then the line is parallel to the third side. Let's say we have triangle ABC. Now, if the ratio of AX to BX is equal to the ratio of AY is to CY, then we can say that XY is parallel to side BC. Let's have an example. In triangle CRV, AE is parallel to RV. Find X. So as you can see, AE bisects side RC and side CV. And since it is parallel to the third side of the triangle, which is RV, we can say that the two sides, RC and CV, have been divided proportionally. We apply here the basic triangle proportionality theorem, or BTPT. In order to find the value of x, we can form a proportion out of the given sides. So we have 6 is to 10 is equal to x is to 15. Cross multiply, we have 10x is equal to 6 times 15 is equal to 90. Divide both sides by 10, therefore, x is equal to 9. Let's have another example. In the diagram, AB is parallel to ED. BD is equal to 8, DC is equal to 4, and AE is equal to 12. What is the length of EC? Again, we apply basic triangle proportionality theorem. In order to solve for the length of EC, we form a proportion from the given measures of the sides. So we can write 4 is to 8 is equal to EC is to 12. Cross multiply, 8 times EC is 8EC. 12 times 4 is equal to 48. Divide both sides by 8. Therefore, the length of EC is equal to 48 divided by 8, and that is equal to 6. Let's now have the extended parallel proportionality theorem, or EPPT. EPPT states that if three or more parallel lines intersect transversals, then they divide the transversals proportionally. Say for example, if L1, L2, and L3, or line 1, line 2, and line 3 are parallel lines cut by the transversals T1 and T2, then we can say that the ratio of AB to BC is equal to PQ is to QR. Number 2, the ratio of AB to PQ is equal to the ratio of BC to QR. Number 3, the ratio of BC to AC is equal to QR is to PR. Number 4, the ratio of AB to AC is equal to PQ is to PR. And number 5, the ratio of AC to BC is equal to the ratio of PR to QR. Let's have an example. Let's say we have lines A, B, and C are parallel, cut by the transversals T1 and T2. Find the value of X. So here we will apply the extended parallel proportionality theorem. If we have three or more parallel lines and they are cut by the transversals, then the transversals have been divided into proportional parts. So we can form a proportion from the given in order to solve for X. So we can write X is to 20 is equal to 15 is to 18. Cross multiply, 18 times X is 18X. 15 times 20 is equal to 300. Divide both sides by 18. Therefore, X is equal to 50 over 3, or in simplest form, 50 over 3. We can express our answer in decimal form, and that is 16.67. We can have an alternative solution. We can also write the ratio X is to 15 is equal to 20 is to 18. If we cross multiply, still we will get 18X is equal to 20 times 15, and that is 300. Divide both sides by 18. Still we will get X is equal to 16.67. Let's have another example. Find the value of X. To solve for X, we can form a proportion. 10 is to X is equal to 12 is to X plus 2. Cross multiply, 12 times X is 12X is equal to 10 times quantity X plus 2. Apply distributive property, so we have 10X plus 20. Let us transpose 10X to the left side of the equation. So we have 12X minus 10X is equal to 20. So we have 2X is equal to 20. Divide both sides by 2. Therefore, X is equal to 10. Let's have another one. Find the value of X. So again, we can form a proportion from the given. We can write 8 is to 6 is equal to 10 is to X. Cross multiply. So we have 8X is equal to 60. Divide both sides by 8. X is equal to 15 over 2, or in decimal form, 7.5. Another solution, we can write 8 is to 10 is equal to 6 is to x. Cross multiply, 8x is equal to 60. Again, divide both sides by 8. X is equal to 7.5. Next, find the value of a. We can form a proportion. A is to 20 is equal to 9 is to 15. Cross multiply, a times 15 is 15a. 20 times 9 is 180. Divide both sides by 15. Therefore, a is equal to 180 divided by 15. That is equal to 12. Let's now have the triangle angle bisector theorem. Triangle angle bisector theorem states that the bisector of an angle of a triangle separates the opposite side into segments whose lengths are proportional to the adjacent sides. Say for example, we have triangle ABC. Let's say that AX bisects angle A, meaning, so if AX bisects angle A, it only means that angle BAX is congruent to angle CAX. So if AX bisects angle A and it intersects BC at point X, therefore we can say that the ratio of BX to CX is equal to the ratio of AB to AC. Let's have an example. Find the value of x if A is equal to 10 and B is equal to 15, Y is equal to 12. So here we will apply the triangle angle bisector theorem. A is equal to 10, B is equal to 15, and Y is equal to 12. So we are to solve for x. Since the triangle angle bisector theorem states that the bisector of an angle of a triangle separates the opposite side into segments whose lengths are proportional to the adjacent sides, we can form a proportion from the given. So we can write x is to y is equal to a is to b. Let us substitute the values. So for x, this is unknown. Y is equal to 12, A is equal to 10, and B is equal to 15. To solve for x, we cross multiply. X times 15 is 15x. 12 times 10 is 120. Divide both sides by 15. So we have 120 divided by 15. Therefore, x is equal to 8. Let's have another one. Example, in triangle GMO, ME bisects angle M. Solve for x. Okay. So again, we apply the triangle angle bisector theorem. We can form a proportion from the given. So we can write 8 is to 12 is equal to 9 is to x. Cross multiply. So we have 8 times x is 8x. 12 times 9 is 108. Divide both sides by 8. Therefore, x is equal to 27 over 2. So 108 over 8 in lowest term is 27 over 2. We can express our answer in decimal form. 27 divided by 2 or 108 divided by 8 is equal to 13.5. Let's have another one. Find x. Okay, let's form a proportion. So we have 6 over x is equal to 12 over 18. Cross multiply, 12 times x is 12x. 6 times 18 is equal to 108. Divide both sides by 12. Therefore, x is equal to 9. Let's have more examples. In the figure, RD is parallel to EA. Find x. So as you can see, RD bisects the two sides of the given triangle and is parallel to EA. So here, in order to find x, we apply the basic triangle proportionality theorem. So we can form a proportion from the given. So the ratio of BR is equal, BR is to RE is equal to the ratio of BD is to DA. Let us substitute. BR is 12, RE is 4. Now for BD, how are we going to represent the measure of BD? If DA is x and if BA is 12. So since BA is 12 and DA is x, we can represent BD as 12 minus x. So therefore, we have 12 minus x is 2, DA which is x. So to solve for x, we cross multiply. 12 times x, we have 12x times 4 times the quantity, or is equal to 4 times the quantity 12 minus x. Apply distributive property. 4 times 12 is 48. 4 times x is 4x. Let us transpose 4x to the right side of the equation. So we're going to have 12x plus 4x is equal to 48. 12x plus 4x is 16x. Divide both sides by 16. Therefore, the value of x is equal to 48 divided by 16 is equal to 3. So in the given figure, DA is 3 while BD is equal to 12 minus x or 12 minus 3. Therefore, this is 9. But we are only asked to find the value of x. So x is equal to 3. Let's have another one. If AD, BE, and CF are parallel lines and BC is equal to 9, AC is equal to 27, and DF is equal to 24, find EF. Okay, in order to find, the value of EF, we apply here the extended parallel proportionality theorem. We can form a proportion from the given. So we can write, we know that the ratio of BC to AC is equal to the ratio of EF to DF. Let us substitute. So BC is 9, AC is 27. EF is unknown, while DF is 24. Cross multiply. 27 times EF is 27 EF. And then 9 times 24 is equal to 216. To solve for EF, we divide both sides by 27. (216) divided by 27 is equal to 8. Therefore, in the given figure, EF is equal to 8. Let's have another one. PI bisects angle P. So if PI bisects angle P, it only means that this angle is congruent to this angle. Next, PD is equal to 6. PA is equal to 12. And DI is equal to 4. Find AI. So this is unknown. So in this given example, we apply the triangle angle bisector theorem. Let's form a proportion from the given. So we have the ratio of DI to AI is equal to the ratio PD is to PA. Let us substitute. So we have 4 is to AI, since AI is unknown, is equal to 6 is to 12. Cross multiply, AI times 6 is 6 AI. 4 times 12 is equal to 48. Divide both sides by 6. Therefore, AI is equal to 48 divided by 6 is equal to 8. So those are the different proportionality theorems. Thank you very much for listening. Have a good day.